Let's have a closer look at the impressive engineering project that should have created the fastest car in the world and brought the big names of German car and aircraft industry together, the Mercedes T80. In the mid-1930s, Hans Stuck, one of Germany's most successful and very popular race driver, had a problem. While he was very successful in hill climbs and Grand Prix racing, his new young teammate from Auto Union, Bernd Rosemeyer, turned out to be the new super talent. Rosemeyer came from motorcycle racing and had no experience in how traditional front-engine Grand Prix cars would behave. And so he adapted very quickly and very successfully to the mid-engined Auto Union race cars. The experienced senior driver Hans Stuck knew it would be hard to stay competitive, and so he was looking for another project to become the greatest driver ever. He got the idea of becoming the fastest man in the world. High speeds were nothing new in Grand Prix racing, where the streamlined versions reached almost 400 km per hour during races. During the German record weeks, special prototypes of Mercedes and Auto Union's Grand Prix cars reached more than 400 km per hour on German highways. That was impressive for Grand Prix race cars on public roads, but in the salt flats in America, the two British drivers Easton and Cobb were competing with each other for higher and higher top speeds. In 1937, Easton could already reach over 500 km per hour in his special record prototype with two engines, which was almost 100 km per hour faster than the German Grand Prix cars. Stuck thought it would be great to get this record to Germany, and although he was a works driver for Auto Union, he reached out to Wilhelm Kissel, CEO of their competitor Mercedes and his previous employer. Mercedes had lots of experience in building record cars. They had the equipment, the staff, and, in contrast to Auto Union, the money to fund such a project. Kissel liked the idea, and also German politics supported the project to get the record to Germany. The British record cars used two engines with around 1,300 horsepower each. Mercedes, on the other hand, just developed the new DB601, the 34-liter V12 engine for the new Messerschmitt 109. Another reason for Stuck to approach Mercedes. Special about this engine was the direct fuel injection and the A configuration, which means that the engine is basically upside down. So it's an A engine rather than a V engine and has 60-degree bank angle. The standard power output was 1,100 horsepower, but for record planes it could be turned up to 2,700 horsepower. So a slim aircraft engine with the required power output. In 1937 the project started with the following structure. Mercedes outsourced the vehicle concept to their former technical director, who now started his own design company, Ferdinand Porsche. The connection between Porsche and Mercedes was still very close, because Porsche's first prototypes of the Volkswagen Beetle were manufactured at Mercedes in Sindelfingen. The well-known aircraft company Heinkel manufactured and paid the bodywork, and Hans Stuck himself should pay for the record runs. The car itself undoubtedly is a Porsche design. It's mid-engined, has two large tubes either side with an oval cross-section to increase stiffness, trailing arm front suspension with torsion springs, and two rear swing axles with torsion springs. These are all features we know from Auto Union Grand Prix cars, Porsche's lost supercar P52, and things we will see later on at the Volkswagen Beetle and Porsche 356. Special is the packaging of the large 12-cylinder engine. Because of its upside-down arrangement and dry sump oil system, the bodywork can be very close to the block and use the space very efficiently. The driver sits in front and the cockpit blends in perfectly with the massive engine block at the back. Also, we can see something here that looks like an aluminium monocoque for the driver sitting between the frame. The steering wheel was large because this 2.8-ton vehicle had no power steering. To allow space for driver's legs, it was flat at the bottom. These are all features we will see much later in motor racing. Although at first Mercedes planned to run the car in America too, like their British competition, it pretty soon became clear that it wouldn't be a good idea because Germany would send their latest military aircraft engine to America and risk that technical details could be discovered. On the other hand, Germany wanted to show what their new Autobahn system was capable of, and decided that the car should run on the new Autobahn close to Dessau with its 10-kilometer long straight. The track here is 29 meter wide and bridges have no center support, so you can use the maximum width for record runs. But this also meant that the T80 needs to reach high speed as quickly as possible. To get the massive power on the road, Porsche designed the car with two driven rear axles, so there are four wheels transmitting the torque. A large torque converter and a fixed gear ratio transmitted the power to the back, so there was no extra gearbox required. Additionally, Porsche created a mechanical traction control which constantly looked at the speed difference between front and rear axle. If the rear axle should spin, the system would recognize the speed difference and reduce torque automatically, so the driver can concentrate on driving. In the meantime, the British competitors raised the bar for the land speed record step by step, and so the target speed for the T80 needed to be increased too, so the car should now reach more than 600 km per hour. But that was a problem. The only tire manufacturer who could reliably produce tires that could run up to 700 km per hour was Dunlop. But the German record car shouldn't be equipped with tires of the competitors. The German tire manufacturer Continental wasn't quite there yet, and also the large spoke rims showed extensive deformations at around 500 km per hour. And they also needed an engine which was able to do that. Mercedes developed the DB601 engine further and created the DB603 as its successor. It now had 44.5 liter capacity and could be turned up to 3,500 horsepower. Also, the aerodynamics of the car was on another level. The car was 8.24 m long and only 1.74 m wide. The front radiator had an intake underneath the nose and a very smooth exit into the underbody flow. At the back we can see a real diffuser on a car in 1939. The upper side of the bodywork is smooth, slightly downwashing behind the middle, and has a kick up at the back. The second rear axle has a smaller track width to create some bow tailing at the back and to reduce drag. The large rear wheels are covered by massive wheel arches that work as high-speed stabilizers at the same time. They increase the side area behind the center of gravity and reduce the crosswind sensitivity. If you want to know more about crosswind behavior, check out my other video in the description. At the same time, these large wheel arches enclose the diffuser at the sides and increase its efficiency. Since Heinkel, the famous aircraft manufacturer, designed the bodywork, they could use their knowledge of wings to increase downforce of the vehicle to get the power on the ground. The idea, back in the day, was to use wings at the car's center of gravity, like the Opel rocket race cars 10 years earlier, to avoid any balance shifts at higher speeds. And so they designed a bodywork with large wing roots at the side and side wings which they could swap for different sizes. They then produced a scale model of the car in summer 1939 and went to the Zeppelin wind tunnel in Friedrichshafen to find the perfect downforce setup. In the end, they reduced the wing area to 3.65 square meter to get enough downforce to bring the power on the road, but to have as little drag as possible at the same time. If we have a closer look at the wing profile they were using, we can see that they had a pretty flat pressure side for low drag, had around 8-degree angle of attack, a rounded underside with flat recovery zone at the back, and a leading edge with a relatively small radius. This makes the profile a bit more aggressive and less forgiving for angle changes, but this is a car with very little dive, so such a profile should be fine for this application. September 1st, 1939, the Second World War started. In October, the T80 was still running on Mercedes' test bench, but by spring 1940 a final report was written and the car stored in Stuttgart. The engine was sent back to the German Luftwaffe, and you can see the car today in the Mercedes Museum in Stuttgart. Hans Stuck couldn't fulfill his dream of becoming the fastest man in the world. Although he came up with the idea for this project, he stayed auto union works driver during the development of the T80 and therefore Mercedes decided to use their own race driver Rudolf Caracciola for the T80. I hope you liked this look back in history and see you at the next video.